everyone. Welcome to Gate Academy Global. So here we are having the first session of crash course of communication system. So you are all aware about that the subject communication system and electromagnetics are very important, and we are going to discuss the important topics of communication system. And as you have seen the introduction of the communication system, so what are the topics I am going to cover? You might have seen that introduction video, and which chapter of communication system is for which branch, that I have already told in my introduction lecture. Okay, so let's greet everyone who are here. So good evening Ajay, and good evening Raksha, Shubham, Arijit, everybody, good evening. So what you want to make me, what you want from me in this particular crash course, let me know, so that I will be discussing the course according to that. So first of all, let me know what are the things which you are expecting in this crash course. See, remember that this is the crash course, so every topic cannot be covered in detail. The course duration will be around 35, 40 or maybe up to 45 hours. So depending on the important topics, we will focus on that particular topic. We will not go to the every derivation of the subject. So Nitish, you are from the electrical engineering. So this is also for the electrical engineering students. But in which way, that I am going to tell you. See, for the electrical engineering students, this subject is for ESE. Okay. This subject is for ESE and UPSC. Remember that this subject is important for ESE and UPSC. If you see the syllabus of UPSC exam in the future, if you will prepare for the UPSC exam from the electrical engineering, that time you have to study the communication system. So this is the best course for you. If you want to cover the some basic portion of communication system, then this is the best course. Okay. So this time you can cover the basics of every topic with questions, and then you can go to the previous year ESE questions, and you can solve the previous year UPSC question. You will see that how easily you are going to solve the questions from the communication system, because the level of the questions in ESE and in UPSC from the communication is very easy for electrical students. Okay. So let me take the other queries, because before going to the main topic, let's discuss first, because this is the introduction lecture. So let's introduce ourselves, and so that we can get familiar with each other, and then we will be having the good communication. So after that we will start the main topic. Okay. So the PD students should attend, if they want to revise, they should attend Chandrima like communication. Abhyas Tabartor, that will happen in the communication as well, after EMT or after the finishing of this crash course of the communication system, because everybody will study the communication system when I will finish this subject. So after that, if I take any practice session, that will be beneficial for you, because many of students or many of you have not studied the communication system yet. So for that, if I start any series, question series, then they will not be able to appear in that particular series. So once we cover the crash course of the communication system, I will start the practice question as well, and the name of that will be capsule series. Okay. So entire theoretical part will not be covered. The diploma students should also come if they are having the syllabus in communication system in their syllabus, then they should also join. Digital communication I will take very much seriously, and I will focus more on digital communication, because many of you have doubts in digital communication only. Noise in digital communication part, that part I will also cover through the questions and some basic portion and some important criteria. So yes, I will focus on digital communication, random variable. I will try to focus those part of communication in which the students are facing difficulty. Okay. So but as you know that we are having the electrical students with us, instrumentation students with us. So for that we have to start from the basic only. Okay, so remember that the EC guy should think that if I take the time in amplitude modulation and angle modulation, it may be easy for the electronics and communication students, but that is very important for the electrical and instrumentation students. So that is why we have to start from the basic only, and that is your amplitude modulation and angle modulation. Not complete theory, but the many portion will be covered, not complete theory, but many of that will be covered. And this theory weightage of the Nitish, weightage of this subject in GATE, if you are from electronics student, electronics background, then the 10 to 12 marks will come from this particular subject. And definitely after this crash course you will be going to attain the number marks, that is 6 to 7 marks that you are going to cover after this crash course. And if you want to cover complete 12 marks, then you have to take our full course. From anywhere you can study the full course, but from this crash course I can guarantee that you can you are able to achieve the 6 to 7 marks from the subject. So EMT crash course will also come later. Okay, at a time we cannot simultaneously start both the subjects, because I am having already one session for EMT. So is there any instrumentation students? So instrumentation students, there are 4 chapters, that is amplitude modulation, angle modulation, and the baseband transmission and bandpass transmission, and these 4 chapters are also for the electrical students. So for the electrical students and the instrumentation students, these 4 chapters are important, so that I am going to cover in a good way, so that you will be not facing any problem in this particular chapters. Important chapters will be covered. Yes, important chapters will be covered. Yes, this course will be on YouTube only, and this is free of cost for everybody. For everybody it is free of cost, because this is a YouTube live. No video will be privatized later. So all video will be there for lifetime. So okay, for all the videos that I will cover here, all the videos will be there for the lifetime, and you don't need to bother about the live session or anything which will be privatized. Nothing will be happen like that. And we will make a proper playlist for this particular crash course. So after this session I will go to the editing room, and I will discuss them, and will tell them, then they will make a proper playlist for this crash course of communication system. And from the now onwards, in every time when I will create a link, I will also write the name of topic name in the title. Because here I have not written the title or the topic name for today, because we have to prepare we have many work. So for that we have to prepare the link for the next 10 days. So that's why I have not mentioned any topic, because I don't know which day I will reach to the which topic. Okay, so I will mention the name of the topic in the Telegram group. So who have not joined the Telegram, please join the Telegram, and I will be sharing the topic in the Telegram group. So please share the Telegram group. Kalyan, share the Telegram group. Once more. Telegram group share kar do. Okay. Yeah. Okay. So I think all are ready for the first topic. Optical communication weightage is very less, Nitish. So yes, which branch from? How many days? Yes, so how many days this course will run? So every day we will take 1.5 hours classes, so it will go around 1 month. So the crash course will finish in 1 month. Okay, in 1 month it will be finished. So don't think that it will stop in middle. So the communication crash course will run every day at 6 p.m. okay, in Gate Academy Global channel without any interruption. It will be continuing until the finish of the course. Okay. Thank you, Ashutosh. Let's start. Yes, Zed. Thank you. Okay, Manisha, thank you. Welcome. Yes, instrumentation, Nitish. Instrumentation. I told you that there are 4 chapters: amplitude and angle modulation, baseband and bandpass. And optical communication is having very basic thing, which is up to the numerical aperture, number of modes, etc. Okay. Yes. In Sunday, no, there will be no classes on the Sunday, at least in this month. So EMFT, the course will come for EMFT also. Yes, there will be a crash course for EMFT also. It would be enough for GATE EC 21, but out of 12 marks or 10 marks, I can guarantee to get you 6 to 7 marks through this crash course. So I cannot guarantee for the full marks from the crash course, but I can guarantee you 6 to 7 marks from this particular crash course. Yes, Anurup, thank you. Yes, if you have not read communication, Aditi, then also it is beneficial for you, because just you need to know about the basic concept of signals and Fourier transform. The Chandrima, the optical communication is already present in GATE Academy Global channel. If you will go to the playlist, you will find the playlist for the radar and optical communication, and there I have covered the basics of optical communication which is required for instrumentation, guys. Okay. Latest technology related, you have to read by your own, that is from the Google search only. That cannot be covered in the class, because we know that this is the crash course. We cannot cover every point of the communication. We cannot relate to the real life. Telegram link, please open it with the Telegram, because when you directly click on the Telegram link, it will go to the Chrome or it will go to the any browser. That will not work. So this link should be open in the Telegram itself. Okay. So if the Telegram will not work, so please go to that go through that, or I will give you my number. You can WhatsApp me. I will add you on Telegram, because whatever I will write here, I will be sharing the PDF of this course in Telegram group. Again, there will be no need to write each and every point by you. You can directly take the printout, but because the board is black, so that may be a difficulty for you, but the PDF will be provided in the Telegram itself. So you can join me on the Telegram, and I will be giving you my number. You can note it down, and if you are not able to join this Telegram group, then WhatsApp me on this number. I will be adding you on the Telegram, and I will be sharing on the daily basis the PDF of the course. The weightage of the optical communication, there is nothing like that, because sometimes they will ask the question or sometimes not. There is a coupon code for communication system and EMT, but that is for the VOD lectures in English. Okay, Yogesh. So if you want to take the coupon code, if you want to buy the full course, then you can contact me on this number. Please WhatsApp me first, then I will be discussing everything in the WhatsApp or Telegram. Okay. Okay, so let's start with the subject. So everybody has noted down this number. Let me know everybody is ready for the session, and everybody has noted down this number, so you can contact me in this number. Yes, optimal probability distribution will also be covered. Everything will be covered which is required for the EC or EE or instrumentation students to get 5 to 7 marks, whatever will be required. I will be covering each and everything in this particular crash course free of cost for you guys, and just for the extra preparation you have to buy the full course, and that is you can understand that we cannot 100% provide everything for free, but I will be guaranteeing you that you will be having 5 to 6 marks if you have not prepared the communication system yet, and if you face any problem in the communication system, that will be covered in this crash course, and you will get some confidence in this subject. So after studying from here, you can opt any full course from anywhere. There is no foundation for you. Yes. So let's start, and everybody has noted down this number. Okay. So because today is the introduction part, so we will be studying some introductory part of this subject. So what is the communication system? What is the system? What is the communication system? So the system in which we transmit the information. We transmit the information in the form of energy. See, if we want to communicate, we send some signal from somewhere to somewhere. Okay. So here we are going to see is what is the communication system. If I say what is that communication system, everything I will provide in PDF form, so just listen everything, and you want to make a note, then you can make a note by your own. Okay. So this is the topic, or this is the subject, communication systems. So if I say what is this communication system, so it is a system in which information is being transmitted. Information is being transmitted in the form of energy. Information is being transmitted in the form of energy from source to destination. So we are talking about the communication system. So what is that communication system? So we can define the communication system, that is nothing but the convey of information. So when we transmit a information from the source to destination in the form of energy, when we transmit the information in the form of energy from source to destination, okay, when the information is conveyed from source to destination, so that particular system which is required for this type of convention is called communication system. Okay. So if you want to transmit a information from source to destination, there will be number of blocks which will be present in the system, and that will reach to the destination in the form of energy, that is known as electromagnetic wave. Okay. So this is what the communication system is. So let's understand what is the block diagram. What is the block diagram? Okay. So what is the block diagram of the communication system? Each and everything I am going to write very good way, so that you will get the PDF of this particular course, and directly you will be having everything on your hand. Okay. So that's why I will take some time to write, so please have patience for it. So this is the block diagram of communication system. Let's make a block diagram. Let me draw the block diagram of the communication system. And I will request you all that if you are coming here, just have patience and listen each and every point, each and every point carefully, and maintain the decor of the class. Okay, don't comment anything which is not required here, because that will not bother me, but it will not be good for other students. So please maintain the decor of the class, because in YouTube everybody, write anything about any faculty, they say like somebody is saying that he is online, who is online. So if you are here, then be here with full attention. Be here with full attention. 1.5 hours you have to spend with me, and I will make sure that how you become master in communication. Okay, so let's write. So this is now the source, and here it is input transducer, and this is your transmitter, and it is channel, this is receiver, and output transducer, and this is destination. And who will be studying this subject first time, they will learn everything, and who will be just revising the communication system, they have to keep patience, because the thing will go slow in the starting, but as we will get familiar to each other, once we get tuned to each other, we can move fastly. Okay. Yes, hello Mahen. Will communication will be available in a year pack. There are only 2 courses, 1 month and 2 month. So this is the block diagram of communication system. Okay. So in communication system we will be having some source, and what this source will be having. So this source will be having some information or some messages. So messages will have some information. So which kind of message it can have? So generally we talk about the voice signal or the speech signal, voice signal, and it is having a frequency range from 300 to 3400 hertz. Okay. Generally the source may generate, like I am the source, I am generating some information, I am generating some voice, so that is having the range 300 to 3400 hertz. So that is generated by the source. We can have some audio signals, and these audio signals are having a frequency range 20 hertz to 20 kilohertz. Okay. Now we were having a video signal as well. So this video signal we will be having frequency up to 5 megahertz. So those students who are studying it first time, he or she will solve the gate question today only. For the first time, even if you are attending the communication class for the first time, you will be able to solve the gate question from today only. We will solve the question from the gate also today itself. Just the thing is that you have to know about the Fourier transform. Just that thing is required. Now this source we are having voice signal, audio signal and the video signal, and it is generating the signals, and it will go to the transducer. So what is the purpose of transducer? The instrumentation students can understand this very clearly, that the transducer work of the transducer is it converts the signal energy from one form to another form. Okay. So it converts the signal from one form to another form. It means that if I am generating a voice signal, like my voice is generating, so my voice is a sound wave. My voice is a sound wave. So this sound wave is a non-electrical signal. So here we can have a non-electrical signal. Okay. So here we can have a non-electrical signal. So what is the purpose of input transducer? If the signal which is generated by the source is non-electrical signal, so the purpose of the transducer is to convert that non-electrical signal into electrical signal. So this input transducer will convert this non-electrical signal into electrical signal, okay. So this is signal. So non-electrical signal is converted into electrical signal. Now what is the purpose of transmitter? So the transmitter does some modification, because if we want to transmit a signal from antenna, if we want to transmit a signal from some wire, we will be having a suitable signal which can be transmitted through the particular medium, because this is the channel. Whatever will be the output of the transmitter, that will pass through the channel, and what is suitable for the channel, in that form we have to convert our signal. So this this electrical signal has to be converted in the form which is suitable for the channel. So what is the purpose of the transmitter? So the purpose of the transmitter is to convert the electrical signal into a form which is suitable for channel. So you can write here the purpose of transmitter. The purpose of transmitter is it converts the signal. It converts the electrical signal into a form which is suitable for channel. So it transmitter converts the signal in the form which is suitable for the transmitter. Okay, so this is the purpose of the transmitter. It will do some modification. It will do some modification to convert the signal in the form suitable for the channel. So this transmitter will do some modification on the electrical signal so that it can be transmitted through channel. Okay. Have you got this thing? Yes, Nageshwari, you can get the EMT course alone in English. You have to visit www.gateacademy.shop. Now, the channel can be two types. It can be a wired channel or it can be a wireless channel. So, wired channel, example of the wired channels are coaxial cable, optical fiber cable, etc., twisted pair cable, etc. Okay, and in wireless we are having the free space, and underwater we can say that is also a wireless transmission. Underwater the transmission can be wireless also. Okay. Now, whatever be the signal which has been converted into the form suitable for the channel, that will be received at the receiver. So what is the function of receiver? What will be the function of receiver? Because you have done some modification in this electrical signal, you have to convert your signal into the same form. This was the actual electrical signal which was generated from the non-electrical signal. So that is the actual information that you are having. But when you pass it through the channel, when you wanted to pass it through the channel, you have done some modification. Means you have changed your information into the suitable form which can be converted through the channel. So which can be transmitted through the channel. So you have converted this electrical signal. So what you have to do is you have to undo your process. You have to undo all the modification that you have done in the transmitter. So what is the purpose of receiver? So it does undo all the modification done at the receiver transmitter. So what is this purpose of receiver? It undo all the modification. It does undo all the modification it undo all the modification done at the receiver, done at the transmitter. So this is the purpose of receiver. Now once you undo all the process, the same electrical signal which is achieved by the input transducer, you will get some at this point, somewhere here. At this point, this will be the electrical signal which you have converted. This is the electrical signal. So same electrical signal you have achieved. Now what is the purpose of output transducer? If you want to get the same information which you have transmitted, that non-electrical signal, then this output transducer again converts that electrical signal into non-electrical signal. So here you will again get that non-electrical signal back, which is your original information. And so this is reached to the destination. This is reached to the destination. So the simple example is our one-to-one communication. Like suppose you are sitting in the class, if I am speaking, then my voice is a non-electrical signal. It has been converted into electrical signal with the help of this mic. So this mic is an input transducer which converts the non-electrical signal into electrical signal. By some wireless medium, it has been reached to the receiver, and that receiver will convert that particular modified signal into that will do undo all the process, undo all the modification that has been done at the transmitter. So the receiver will change the signal into an electrical signal, and then with the help of the speaker, that speaker is your output transducer, that is again converting my original voice into the sound wave. So that speaker is converting a electrical signal into non-electrical signal in the form of sound wave, so that can be heard from the ear. So that will be your communication. Okay, so I hope you have got this. Mohammed Saif. Yes, as I told you in the initial, and if you have not seen the introduction, you can please watch the introduction. This course is for electrical students, electronics students and instrumentation students. This course is very much useful for all these three branches, whether it is the GATE exam, whether it is a BARC exam, whether it is a ISRO, whether it is a ESE, whether you are appearing for UPSC. So all kind of exam you will be facing in future, this particular course are going to help you. So please, if you are coming here to watch, so watch it completely, because if after attending one or two classes, if you will go, you will not learn anything. If you are coming to the class, so be regular in the class, be regular in the class. Okay, so don't use that. Yes, Nilanjana, understood. Okay, so don't do like that. We don't need to go to the internal circuitry of this block. Okay, so that is not required. What is the internal circuit of the input transducer? That instrumentation guy can understand, I think, very much clearly, that what is actually the transducer. But for other students, there is no need to understand the internal circuitry of the block. That is the sonar system. There is a different way for underwater transmission. There is possibility, if you will understand EMT, then you can understand how the electromagnetic wave can propagate through the water. So tell me that how many of you are going to be regular in the class? because if you will not be regular in the class, so my effort will not be worth for you. So please message me once how many of you are going to be regular in the class, so that I will be taking attendance kind of thing from you guys, that whether you are here or not. Every day I will be starting with calling name of everyone who is saying that they will be regular in the class, like Rohit, Dolly, Srestha, yes, Shubham, okay, Chandrima, Rohit, Sheikh, Deepak, yes. So I will be calling your names every time when I come to the class. Very nice. So this type of response is important to keep the faculty motivated. Okay, so that is for you only. And if you keep me motivated, I can give you more and more information about whatever you want from me. Because if the class will be dull, then the motivation will also go down, and after few days, which actually happens in every YouTube session, in the first session we will always have peak number of students, like 200 students will come, 300 students will come, 500 students may come. But when after 2 to 3 days class, the students are not attending the classes, and they look for another channel, they look for another faculty, they look for another mentor to make them learn. So that will not work. If you want to learn something, that will not be working. You have to be stick with one. Whether you are following anyone, it does not matter. If you are following a simple one faculty anywhere from anywhere, you have to be stick with them. Okay, so then only you will be going to learn something. That is important. I am not saying that you have to learn from me only. From wherever you are learning, whether you are learning from the textbook, whether you are learning from any YouTube session, so please be regular whatever you are attending. So that will be beneficial for you. Just my suggestion. Yes. So I will be calling everybody's name who is coming here and saying that they will be regular. So that I will be going to be note down in my copy, and I will be calling you, right? So please be, if you are saying that, be sure that you are going to attend. Okay? Yes, yes. So I will take a screenshot of everybody who is saying yes. Okay. The voice signal which you speak and the audio signal which you listen. Unique. Yes, school, college, you are not going to the college, right? So you should be having that attendance kind of thing in at least YouTube, because we are not going to attend any classes in the college now, in this year at least. Yogesh, if you want to take the full course, you have to visit gateacademy.shop. gateacademy.shop. Thank you, Akshat. Only on random. That is okay. If be honest with you. Be honest with you. If you are coming on the random variable, no problem at all. Whatever you want to learn, be regular in that particular topic. If you want to learn whole communication, be here from start to end. If you want to learn digital communication, so be there in the digital communication. So that is important. Thank you, Ankit. Telegram students usually ask Ankit question from in the Telegram, and Srestha, just so kind of you. Okay, so that is the basic thing. So let's move to the next topic, because we are saying that this transmitter does some modification. So what kind of modification it does? So the modulation operation which is performed by the modulator is performed at the transmitter. So transmitter does some modification. So what that type of modification is called modulation. Okay. Okay, that internet problem I cannot understand. Okay, in the morning Das sir is taking the classes, and okay, you are attending those classes and he is taking attendance every day. Yes, you know Nilanjana, I also message sometimes in his session, and he sometimes call my name also. So you know that I just go to his session and just say him good morning, because he is a very good friend of mine. So I will be just pinging him in his session. So yes, I am going to discuss the numerical also, Aradhana. Today only I will be going to discuss some numerical. So let's go to the next topic. So I am saying that transmitter does some modification. Okay, as I just said that the transmitter does some modification in the signal. So which kind of modulation, which kind of modification it does? So the modification performed by the transmitter is called modulation. Okay, I am writing here. Modification performed by the transmitter is called modulation. So I am going to tell you the what is actual definition of modulation. So let's write the definition of modulation. So what is that modulation? So it is the process, I will write some small definitions. It is the process in which characteristics of one waveform varies in accordance with the characteristics of another waveform. It is the process in which characteristics of one waveform varies in accordance with the characteristics of another waveform. This process is called modulation. This process is called modulation. That means we will be having two signals. To perform modulation, we should have two signals. Okay. So characteristics of one signal should vary accordance with the characteristics of another signal. So there will be one signal which is fixed, whose characteristics will be fixed, and that characteristics should be varying according to the another signal. So this signal will change everything about this signal which is having the fixed parameters like amplitude, like phase, like frequency. So we are having one signal which can have a fixed parameters that is changing, and this signal is nothing but a sinusoidal signal. So any sinusoidal signal can be defined with the help of these three parameters. First, amplitude, second, frequency, and third, its phase. If we say we are having the three things which is amplitude, frequency and phase, we can write the sinusoidal signal. So that sinusoidal signal is having a parameters or the characteristics which is amplitude, frequency and phase. So these three parameters should change according to your information, according to your message signal. So these three parameters, amplitude, frequency and phase, should change according to the message signal. So this message signal will superimpose on this carrier signal, which is generally used to say carrier signals. So we will say that we will learn that what is that carrier signal, but here we are having the sinusoidal signal which is having the three parameters, amplitude, frequency and phase, and these parameters are going to change according to the message signal. This message signal can be your sinusoidal signal, it can be a triangular signal, it can be a square signal, it can be any random signal which is defined by some random variable. So this message signal will change characteristics of this another signal. So we should have always two signals. So this is the characteristics of one waveform varies in accordance with the characteristics of another waveform. So we should have always a two waves. Uday, who is not able to join Telegram, please, in the starting of the video I told my number, please note that number and WhatsApp me in that number. So I will send the Telegram link and then you can join, because whatever I am going to write here, I will be sharing the PDF of this in the Telegram group. Yes. Everybody, please be patient. I will be going to share my number in the later of the session. Okay. So it is the process in which there is another definition. There is another definition which is it converts low frequency signal into high frequency signal. Okay, so it converts low frequency signal into high frequency signal. So basically it is also known as frequency translation. So it is also known as modulation. It is also called frequency translation. Okay, it is also called frequency translation because it is converting the frequency from low frequency to high frequency. So that is a modulation. Modulation is also known as frequency translation. So there are two definitions which we are going to learn in the modulation. This will give you the amplitude modulation, angle modulation, frequency modulation, phase modulation. This definition will give you what? Amplitude modulation, frequency modulation, phase modulation. Okay, and this is going to be a modulation in general. This is going to be a conversion from low pass signal to high pass signal, or conversion from low frequency to high frequency signal, or low pass to band pass signal. So that is the important thing which we are going to learn today, is the frequency translation. So our today's topic will be actually a frequency translation. Okay, so frequency translation, why it is required, and some question from this particular topic that is asked in GATE, that I am going to cover for today's session. Clear? Yes. So how can we convert this low frequency signal into high frequency signal? So we will be having some block. Just the thing which is required here to learn this type of modulation is just the basic of the signals, just the basic of signal. And because many of you have attended the basics of signals in your morning session in YouTube, so I am considering that you are able to understand what is the signal. So here we are having a block. This block is called balanced modulator. This block I am denoting it by balanced modulator. So the block which performs modulation, is called balanced modulator. Okay, so anything and not balanced modulator exactly, the block which performs modulation is called modulator, and we are giving some name, that is balanced modulator, and we will see that what is actually balanced modulator. So here the term which is important for us is modulator. So what is the purpose of modulator? It performs modulation operation. Modulation operation performs by the block known as modulator. Okay, so modulator performs modulation. Okay, so here we are going to have a low frequency signal, okay, because we wrote that what we have written here is a low frequency signal is converted into high frequency signal. So the input should be a low frequency signal. So input should be a low frequency signal and the output should be high frequency signal, that we have to convert. Okay, this low frequency signal should be converted into high frequency signal, and that is called modulation. So that is performed by 7:30. So low frequency signal is being converted into high frequency signal, and this is performed by the block modulator. And here we have written, as I told you, that we need two signals. So one signal is a low frequency signal. Let us say this signal is empty, and balance modulator, suppose this is a carrier signal. Okay, let us say that is a carrier signal. For time being I am just denoting, many of you are aware of it, carrier signal. So I am writing here carrier signal, and I will give you the information why it is called carrier signal. I will give you information about that also. So that is, say AC cos omega CT, and the phase is 0. If the phase is not given, we take the phase of the signal is 0. Okay, so we can write like this also. So here we are having the three things, as I told you that the three parameter we should know. First is amplitude, second is carrier, and the third is phase. So what is this? This is the amplitude, this is the carrier, and this is the phase. So these three parameters we can easily write the sinusoidal signal with the help of these three parameters. And now we are having the message signal. So the purpose of the balance modulator, what it does is, whatever signal you will give input to the balance modulator, if I give a number of signals, it will give you the product of the signals, product of input of the signals. So if I am giving the two signals at the input of this balance modulator, it will give me product of these two. So because in the input we are having two signals, it will provide the product of these two signals, which is MT into AC cos omega CT, because the phase is not given, so it is 0. Okay. Now the low frequency signal I am saying, let us take some low frequency signal for time being. Let us take this low frequency signal is denoted by okay, suppose this is the frequency FM, this is 0, this is minus FM, and this is your Fourier transform of the signal, okay, and this is F. So this is the Fourier transform of our message signal. The low frequency signal, this low frequency signal is having a frequency spectrum. This is the spectrum of the message signal which we have given in the input. So this is your message signal M of F, and we are getting y of t is equal to mt AC cos omega CT, because this modulator will give you the output which is product of input. So input is mt and AC cos omega CT, so we get the product which is mt AC cos omega CT. Now we are assuming that this is a, suppose message signal mt and having the frequency FM. So what we can say that is, what is the bandwidth of the signal? Can anybody tell what is the bandwidth of the signal? What is the bandwidth of the signal? what is the bandwidth of the signal? The bandwidth of this signal, yes. So someone is saying 2 FM, 2 FM, 2 FM. So everybody, most of you are saying that 2 FM. Yes. So the one important thing that you have to learn from today is the bandwidth. Listen everybody, the bandwidth is always calculated from positive side of spectrum. The negative frequency does not exist in practice. It does not exist in practical life. The frequency that exists only is positive frequency. So the bandwidth is always calculated from positive side. Remember this point, this is very important, and many of you confused with this term. So we have to calculate the bandwidth only from the positive frequency. So what is this positive frequency? So the positive frequency, the maximum value is FM and the minimum value is 0. So the bandwidth of this is FM. This is bandwidth. So remember this point. Remember this point. Okay. So let me write here, bandwidth is always calculated from positive side of a spectrum. So we think that why we represent the negative part, because because we know that in practice we are having only positive frequency, then why we represent the negative part of the signal. The negative part of the signal is always a mirror image of the positive part. That is another important point. Whatever will be given to you in the positive side, the mirror image will be present in the negative side, whether it is given or not. Whether it is given or not, the negative side will have the mirror image of the positive side. Okay. Now the negative side is given because of the cosine term, because if we say the cosine term or the sinusoidal term, all the type of signals we are having in our practice, most of the signals are representable in the form of sine and cosine. All the message signals, most of the message signals, be specific if we want to be specific, all, not all, but many of the message signals are representable in the form of sine and cosine. So if they are representable in the form of sine and cosine, then if we convert this sinusoidal signal or cosine signal in the form of exponential, we will be having the two type of terms. Suppose I write sine theta, so what I can write is e to the power j theta minus e to the power minus j theta divided by 2j. So if this theta is having some frequency, we will be having positive theta and negative theta. So we are having the two terms which is positive and negative. So that is why on paper when we represent the spectrum, we get the positive side as well as negative side, because this term will give you the positive side and this term will give you the negative side, and that is why we are having the positive as well as negative in the spectrum. Okay. So ye positive and the negative. So this is why we have the negative frequency. The concept of negative frequency comes from this sinusoidal and cosinusoidal signal, because they can have the two frequency. If we divide it into this form, exponential form, so we can have the two terms, and one is representing a positive frequency and another is negative frequency. That is why we are having it there. Ajay, FM minus 0 is FM. Yes, Ajay, FM minus 0 is FM. The highest frequency minus lowest frequency. The formula for the bandwidth is highest frequency minus lowest frequency. In the positive side, highest frequency minus lowest frequency. The highest frequency is FM, the lowest frequency is 0. So FM minus 0 is FM. So this is why we have, okay. Now, any doubt? Any doubt? the information is yes, the information is uniformly distributed in the positive side and negative side. We always consider positive frequency. Yes, Ajay, I hope I have answered your question. And we are not having the sinusoidal signal as a carrier signal because the sinusoidal has imaginary part. So because of the practical reason we are not having the sinusoidal part, we use cosine. Suggest book for solving problems. So there are many different books. Ajay, just now I told you that because of the practical reason, because of the imaginary term present in the sinusoidal, because of the phasor representation, the difficulty in the phasor representation, we don't use sinusoidal signal. Okay. So now we are having the high frequency signal. Why we are calling this high frequency signal? That will be answered by drawing the spectrum. See, anything, if we are saying about the frequency of any signal, suppose I will ask you that what is the frequency of Yt. So can you tell me what is the frequency of Yt by looking this expression? If you see the expression Yt is equal to mt AC cos omega Ct, can you tell me what is the frequency of this Yt? Tell me, can you tell me what is the frequency of this Yt? Just by looking the expression in the time domain, can you tell me what is the frequency? Yes. Bandwidth of any other signal is 2 FM. Shivani, don't confuse with this. No. So we are not able to tell about the bandwidth of the signal, right? Okay. So everybody know that what is the bandwidth, what is the frequency of the signal. We cannot just tell by looking this expression. By looking this expression we cannot tell. But how can we tell any frequency of any signal? Why we are able to say that the frequency of this signal is FM? See, listen everybody listen here. If I say MT only, if I say you that there is a message signal MT, what is the frequency? You cannot tell, because MT is in time domain, you cannot tell. But once I will give you the spectrum of the message signal, because we are having the spectrum of the message signal, the spectrum is nothing but the frequency representation of the signal. So frequency domain representation of the signal. Now in the frequency domain we can tell the frequency of the signal. So now we can tell the frequency of the signal is what? FM. The frequency of the signal is FM, we can say, because just that we are having the spectrum of the signal. So to know the frequency of any signal, we should have its spectrum. Okay. If we want to know the frequency of any signal, we should have the spectrum of the signal. So because other than sine signal, we cannot find the frequency directly. Only in case of the sinusoidal signal we can directly tell the frequency of the signal, because we are having the sinusoidal signal, we know the frequency of the signal, which is omega c upon 2 pi. But if the signal is represented in time domain, we cannot tell the frequency until we draw the spectrum of the signal. So we cannot tell the spectrum of we cannot tell the frequency of Yt until I draw the spectrum of Yt. So what is the spectrum of Yt? So taking Fourier transform, what I will get is y of f is equal to 1 by 2 in bracket m of f minus fc plus m of f plus fc. This is the Fourier transform of this signal. So if you don't know, then remember that this is the property of Fourier transform that you will learn in the signals and system. Property of Fourier transform, the modulation property it is called. the modulation property of the Fourier transform is whatever will be the Fourier transform of MT, if you multiply it by cosine, there is one more term which I have missed is AC. The one term which I have missed is AC. So whatever will be the signal is having amplitude, that will be divided by 2, and the spectrum will shift to Fc and minus Fc. The first term is saying that the spectrum will shift to Fc. The second term will give you the spectrum at minus Fc. So see, if I equate it to 0, f minus Fc equal to 0, we get f is equal to Fc. And here, if I f plus Fc is equal to 0, if I make this f plus Fc 0, I will get f is equal to minus Fc. So we are having the two center point, one is at Fc and another is minus Fc. So whatever will the signal present at 0, the 0 signal, the signal which is present at 0 will shift to Fc. The signal which is present at 0 will shift to Fc, and minus Fc, and the 0 signal will also shift to the minus Fc. Plus Fc will be in the right hand side because Fc, this is the positive frequency, so the positive frequency will be in the right hand side, and f is equal to minus Fc, that means it will be in the left hand side. Okay, so this particular spectrum, once you multiply with the cosine term, this spectrum will shift to the positive side, that will shift to the positive side, and that will also shift to the negative side. So once you multiply with the cosine signal, whatever will be the frequency of cosine signal, the spectrum will shift to that frequency. The frequency of this signal is how much? The frequency of this signal is Fc. So what we are saying that whatever will be the spectrum, that will shift to Fc and minus Fc. And what is Fc and minus Fc? This Fc and minus Fc are frequency of this signal. Frequency of the signal by which you are multiplying your low frequency signal. Low frequency signal is multiplied with the signal which is known as carrier signal. This carrier signal is having some frequency Fc, and this signal Fc we are getting the original spectrum to be shifted in the plus Fc and minus Fc. So tell me, you got it or not? Nageshwari, addition of both input, not the product of both inputs, okay, product of both the inputs. Yes, if the spectrum is not given, we have to convert it into a transform. Anyone who is facing any problem? Anyone who is facing any problem? Okay, so we are having one carrier signal, the carrier signal is having some frequency, the frequency let us say Fc, and we are multiplying our low frequency signal with this carrier signal. So what is happening when we are doing so? What is happening? Our low frequency signal is shifting to the frequency by which we are multiplying. The low frequency signal is shifting to the signal by which we are multiplying in the positive side and as well as negative side. Okay. FM is output, FM in output, no, FM in output, no. So let me draw this diagram. Okay, so here the peak value we have got, the peak value of the original signal, understand this point, the peak value, this is the peak value, let us say that value is 1. So the peak value of the input signal was at 0. So now we are saying that by this expression we are saying that it will reach to the FC. So that peak value which was at 0, now it will reach to the FC. So the peak value which was at 0, now it will be at FC, and this will be the difference between these two. So the difference between these two is nothing but FM. This is what you have said, the bandwidth. So this is FM, 0 to this point, 0 to this point, the total width is FM. So now this point is reached to the FC, then this point will reach to the FC plus FM. It means that we are adding FC in the whole axis. It means we are adding this frequency, whatever frequency by which we are multiplying, this frequency is actually adding in the frequency axis. So when you add this 0 plus FC, how much you get? 0 plus FC is equal to FC na. So 0 plus FC, you will get the peak value. So FC plus FM, so you will get the FC plus FM, and when you add this FC to with minus sign, you will get FC minus FM. So FC minus FM, and similarly this is the part of this term, this is the because of this term, because of this term we have got this value. So this is because of M of F minus FC, this term. Now M of F plus FC means what? You have to add the minus FC term, you have to add minus FC. So when you add minus FC to the whole axis, what you will get? When you add this minus FC, you are adding, so minus FC minus FM. When you add minus FC with 0, you will get minus FC. When you add minus FC with FM, you will get minus FC plus FM. So 0 minus FC, that means minus FC. So whatever will be the term at 0, now it will go to the minus FC. So this is minus FC, this is minus FC minus FM, and this is minus FC plus FM, and this will be because of M of F plus FC, this term. Now what is that amplitude? So the amplitude, we have said that the amplitude is AC by 2, so the amplitude will be half. So the amplitude is AC, this AC will be there, or the amplitude is 1, so this AC into 1 divided by 2, so we will get AC divided by 2 here. So this is the your Y of F, this term is nothing but Y of F. Okay, tell me, you have got this or not? You understood this point or not? Sir, adding of the frequency of both the input, yes, adding of both the frequency. If we add these two frequency, we will get some value, and that is the highest frequency which we get. Okay, understood? So what is the bandwidth of this signal now? Now what is the bandwidth of this signal? What is the bandwidth of this signal? Now tell me, what is the bandwidth? No, Sanjana, F minus FC will be at positive side. F minus FC means delaying the signal, and when you delay the signal, it will shift to the right. Okay? Yes, 2 FM, 2 FM, yes, 2 FM. Very good. Okay, so the bandwidth is calculated from the positive side, and the bandwidth will be 2 FM because we are having the highest frequency FC plus FM and the lowest frequency FC minus FM. So we will be having the bandwidth from this point to this point. This is the bandwidth. So the bandwidth is 2 FM. Okay, tell me, everybody clear? Bandwidth of the modulated signal is 2 FM. Okay, so this is the modulated signal and this is the modulating signal. Okay, so this is how we convert any low frequency signal into high frequency signal, and we can understand this by another taking some numerical value. Let us take some numerical value. Let us take this FM is equal to 5 kilohertz. Okay, so let us say the FM is equal to 5 kilohertz, and let us say this FC is equal to 100 megahertz. Okay, so what we are doing is to translate the low frequency signal into high frequency signal. This is the low frequency signal, it is in the kilohertz, and this is megahertz, and that 200 megahertz. So it means it is a very high frequency and it is a low frequency. So this low frequency and high frequency signal are multiplied. This is a low frequency signal, this is a low frequency signal, and this is a high frequency signal, and this low frequency signal and high frequency signal is multiplied with the help of modulator. And when it is multiplied, where it goes? So where it goes, we can see that the original signal, which is having a 5 kilohertz, has been shifted to FC, So here the maximum frequency will be if we use our numerical value, so this will be 100 megahertz, 100 into 10 to the power 6 plus 5 into 10 to the power 3. So this is the high value, this is a high frequency term. So you can say that this low frequency signal, which was 5 kilohertz, has been shifted to 100 into 10 to the power 6, which is centered about 100 into 10 to the power 6. So what is the resultant signal? The resultant signal is called as a high frequency signal, because it is having a center frequency 100 megahertz. Now it is centered at 100 megahertz. Previously our signal was centered at 0. Previously it was centered at 0, now it is centered at 100 megahertz. So now the low frequency signal, this low frequency signal has been converted into high frequency signal. Okay, so in this way the modulation converts the low frequency signal into high frequency signal. So low frequency signal has been converted into high frequency signal. As we can see, this low frequency signal is converted into high frequency signal, and that is why it is known as frequency translation. The signal that was only extended up to 5 kilohertz, now it has been shifted to the 100 megahertz, and it can be now extended up to 100 megahertz plus 5 kilohertz. So it has been converted into high frequency, and that is why it is known as frequency translation. Okay. Now one more thing is that this is a low frequency signal, and tell me the name of the filter by which you can get this signal. The name of the filter by which this signal can be achieved. The advantage of doing so we will see just after this discussion. Yes, so the kind of filter by which we can achieve this type of signal is a low pass filter. The low pass filter is the filter which pass the signal frequency which is less than the cutoff frequency of the filter. So that is done by the low pass filter. Okay, so it is clear to everyone, because this is a low pass signal. This is a low pass signal. okay, because it is achieved by the low pass filter. Low pass filter is centered about origin. Low pass filter always center about origin. The importance of the low pass filter is nothing but the low pass filter is always center about origin. So the low pass filter is the filter which passes the signal frequency which is less than cutoff frequency of the filter. So if we want to achieve this signal, we should have a low pass filter whose cutoff frequency should be FM. So it passes the frequency component which is less than FM. So FM 0 to FM, it will pass all the frequency component which is 0 to FM. So this is the low pass filter, and because this signal can be achieved with the help of low pass filter, we will call it as low pass signal. We will call this signal as low pass signal. This signal will be called as low pass signal. Now tell me by which filter you can achieve this signal? By which filter you can achieve this signal? Yes, Manisha, yes, you are correct. Yes, now we can say that this is the signal can be achieved by the band pass filter because it is having the center frequency other than 0. The filter which is having center frequency other than 0 is called band pass filter. So this is passing a range of frequency. What is the purpose of the band pass filter? If we want to have the range of frequency at the output, so we want to have the range of frequency which is varying from Fc minus Fm to Fc plus Fm. We want to have this range Fc minus Fm to Fm, Fc plus Fm. So if you want to have this type of signal, you have to use the band pass filter. So the band pass filter, we will get the band pass signal at the output of band pass filter. So this is the band pass signal. So what we can say is the modulation performs the low frequency signal into high frequency signal. Okay, modulation performs the frequency translation, so it converts the low frequency signal into high frequency signal. If we talk about the frequency, it is converting low frequency into high frequency. If we say that is a modulation, modulation is also performing it is also converting a low pass signal to the band pass signal. So modulation, if we modulate the signal, we get the band pass signal. Whenever we perform modulation, we get the band pass signal, we get the range of frequency. So that is the question asked in any type of exam. After modulation, we get which kind of signal? First option low pass signal, second option high pass signal, third option band pass signal, fourth option any none of the above, like that. So after modulation, we get band pass signal because it will shift to some frequency. Instead of having the 0 frequency, it will be having some center frequency, that is Fc. So now we can say that this is a band pass signal. So after modulation, we are having a band pass signal. So that is the important point. So modulation is doing a frequency translation. It is converting low frequency into high frequency. Okay. So I am writing low frequency into high frequency and low pass to band pass. After modulation. Okay. Okay, it is clear to you? So is the modulation process clear to everyone? Is the modulation process is clear to everyone? Will any other subject available in English course? No, right now no. Thank you, Raksha. Yes. So, are you ready to solve the question? I will give you a simple question, and if you are ready to solve, let's solve that particular question and we will finish the session, okay, for today. And why we are performing this thing, somebody was asking, so I will tell you what is the need of that particular concept. We will discuss in the next session. Band pass filter you want to understand, okay, so let me understand band pass filter. Let me tell you about the band pass filter in short. That is very basic thing, Manisha. See, I am going to tell you each filter. Everyone, please have some patience. We are having one friend which is having some doubt in the filter. So let me explain this filter concept so that in question she can also participate, right? So everybody should have some patience. Okay, so this is all the four kind of filter here. So this is a low pass filter. So the low pass filter, what it does is, so it will be having some cutoff frequency and it will pass all the frequency component which is less than cutoff frequency. So this is nothing but a cutoff frequency of the filter. Okay, this is not a carrier frequency, this is a cutoff frequency of the filter. So this is a low pass filter. The response of the low pass filter is denoted by h of f, and it is a low pass filter. Okay, so we will be having some cutoff frequency. The frequency which is less than cutoff frequency is low pass filter. So here we will be having again so this is the band stop filter. This is known as band stop filter because it is stopping a range of frequency. So let us say this part of frequency is rejected by this filter. So this is the lowest part, this is the highest part, and this is an example of band stop filter. And whatever will be in the positive side, the mirror image will be present in the negative side for every case. For every case, the whatever will be the positive side, that will be present in the negative side as well. So you can see that this is the plus Fc, so the mirror image is in the minus Fc. So whatever will be in the positive side, that will be present in the negative side. So here also it is in the positive side, so the mirror image is present in the negative side. So this part is rejected by the filter, and only this part of this portion will be passed. This portion will be passed by the filter. So that is why a range of frequency is rejected by the filter is known as band stop filter. So this range of frequency is rejected. So this range of frequency is rejected, that is why it is named as band stop. The range is known as band in the communication. The frequency range is always known as band. So the band is having some range. The range is FL to FH. So FL to FH frequency range is stopped by the filter, that is why its name is band stop filter. And here we are having some cutoff frequency. So what it means that this is the filter in which all the frequency component which is higher than FC. So all the frequency component which is higher than FC will be passed through this filter is known as, so all the frequency which is higher than FC means what? That there can be infinite frequency which can pass through the filter. So that is why this is known as high pass filter. So this is known as high pass filter. And this is a band pass filter because it passes only this range of frequency, only this range of frequency. So it passes only this range of frequency, and out of this range all the frequency component will be rejected. So this is FL and this is FH. Other than this term, other than this range FL to FH, everything will be stopped by the filter. Everything will be stopped by the filter. Okay, after before in this range. So in the range FL to FH it will pass, and outside this range it will reject. So tell me, Manisha was asking about this filter. Manisha, I hope it is now clear to you. Allows only certain range of frequency. Yes, only certain range of frequency is allowed by the filter. It is known as band pass filter because a band is passed by the filter. A band, a frequency range that is passed by the filter is called band pass filter. Okay, so let's solve one question. So this is the question for you guys. So this is the diagram. This question you have to solve. This is the first question. I hope don't look the other questions. Okay, so you have to solve only this question number 1. Only this question number 1 you have to solve. So we are having the two balance modulator. Rohit, yes, we are having a question in which we are having high pass filter. Consider a system shown in figure. This is the question we have. See, this is the value 1 to 3 and we are having the peak value at 1 kilohertz. This is the kilohertz. So this signal x of t, which is input to the balance modulator, this balance modulator is having the value 10 kilohertz. This balance modulator is having the value 10 kilohertz and now it is passed through the high pass filter. So after multiplying these two signals, it is passing through the high pass filter, and after passing through the high pass filter, the signal which we are getting is input to the balance modulator, and again we are multiplying with the signal which is having the frequency 13 kilohertz. So we are modulating the signal two times, first with the frequency 10 kilohertz and another with the frequency 13 kilohertz, and we are having the high pass filter. We have to tell that what are the positive frequency of yt in which we are having the peak value. Presently in this question we are having the peak value. This peak value we are having at the frequency 1 kilohertz. At the frequency 1 kilohertz we are having the peak value. Now we have to tell that in yt which frequency there are peak values. Okay, so many of you have solved because might be you are revising that particular course. So first, for the first time students, it will be the question that the xt is multiplied with the signal which is having frequency 10 kilohertz. After getting the signal, we will pass through the high pass filter, and whatever signal we will get, that is again multiplied with the signal which is having 13 kilohertz, and at the output the frequency which we get where the peak value occurs, that is the question. So there are option 124, 114, 224 and 214. Okay, so yes, option B, many of you have got the answer. So let me draw this. So we are having the signal like this. So this is 0, it is given as 1, this is given as 3, it is -1 and it is -3. This is given in the kilohertz. So this is x of f. Now we are multiplying this signal with the balance modulator. Suppose only one frequency component is written. Suppose in this question, like this is 10 kilohertz is only written, it means that it is having the cosine signal and having the frequency 10 kilohertz. So 10 into 10 raised to power 3 into t. So in anywhere in communication, if you will get only the frequency component, then assume the amplitude as 1 and the phase is 0, and you can write the cosine signal. So if we are having the frequency by which we are multiplying, it always means that we are having a cosine signal. So here you are having x of t, and let us say this point is a, let us say this point is a. So what we will get, just now we have calculated that if we multiply the signal x of t with some frequency or with some cosine signal, we will get 1 by 2 in bracket x of f minus fc plus x of f plus fc. And what is that frequency fc? So this frequency fc here is, this frequency is how much? This is 10. So f minus 10 plus x of f plus 10. So it means that this particular spectrum will shift to 10. This spectrum will shift to 10. That means what? If we equate it to 0, f minus 10 is equal to 0. So it means f is equal to 10 we get. So we have to add this 10 with the whole axis. If I add this 10 with whole axis, what we will get? So if I add this 10, what we will get? You can see that 10 plus 3 13, 10 plus 1 11, 10 plus 0 10, 10 minus 1 is 9, 10 minus 3 is 7. So we are going to get the spectrum from -3 to 3 to 7 to 13. That means this spectrum will shift to 7 to 13. So let's draw that. See, this is the value which we are getting. The value which was at 0, that was at 0. So the value at 0 is 0 value. So we are having the value 0. So the peak value which was we are having was 1. So now we will be having at 11. So this value will be at 11 now, and this is at 13, and this will be this will be at 10, sorry, and this will be 9, and this will be 7. So now it is ranging from 7 to 13. Now it is ranging from 7 to 13. So whatever you have got, you have to just draw the mirror image of this. You don't need to calculate this particular part. Whenever you perform a modulation, whenever you multiply with the particular frequency, you don't need to perform left shifting. Whatever you have done in the right shifting, you have to draw the just mirror image of this. So you have to draw the mirror image. So what you will get, so this is the value which you will get the mirror image. So the 10, there will be minus 10. If it is 7, there will be minus 7. If it is 13, so there will be minus 13, and there it will be minus 9, and it will be minus 11. So this is the value you will get at point A. So this is at point A. I hope it is clear to you. Okay, so now it is clear to you. Okay, now we are having a high pass filter. So what is that high pass filter? So this high pass filter, this is a high pass filter which is having a cutoff frequency of 10. What is the purpose of high pass filter? So the purpose of the high pass filter to pass the high frequency which is having the cutoff frequency 10 kilohertz. So what are the frequency component which is greater than 10 kilohertz? So the frequency component which is greater than 10 kilohertz is this one and this one. In the negative side, magnitude wise, the frequency which is greater than 10. So the frequency component which is greater than 10 is this component and this component. We are having the two part, like suppose A and B, and here we are having this A and B. So the term which will pass through the high pass filter will be A, because the frequency component is greater than 10. So this signal will pass through the high pass filter. So this component will pass through high pass filter. So what we get, okay, so we will get only this part. So this part will be removed after the high pass filter. Okay, so this part will be removed. Okay, so tell me whether it is clear to you. This is after the high pass filter. So this is the point B. This is at point B where we are getting this signal. So the high pass filter will pass this particular signal which is greater than 10. Okay, so it is greater than 10. It will pass the signal which is greater than 10. This is output of the filter. Yes, Shashank, I will tell you about my telegram. Okay, yes. So now next is we have to multiply this signal. Now this is the input to the signal. This is now input to the balance modulator. Okay, so now this is input to the balance modulator. So what will happen? So now we are having, let me write here, now we are having a balance modulator. This is a balance modulator, and here we are having a 13 kilohertz signal, and the input to this balance modulator is the spectrum which we are getting at B, and here we are having y of t. So this B is input to the balance modulator, and now we are multiplying with the 13 kilohertz. So what will happen? So we know that what will happen? We have to add this 13 to the whole axis. We have to add this 13. So add the 13. So let's say 13, we are adding this, all these three terms we are getting. So when we add this 13 plus 13, we get 26. So this means it will move to the 36, 24, and it is 23, and it is minus 3, it is equal to, sorry, this is plus 3, this is 2, and this is 0. So this will happen. So this spectrum which was presently at minus 13, after multiplying with 13 kilohertz, it will shift to 0. It will shift to 0. So now okay, so this term will go to the 0. This will go to the 0, and we will be having the mirror image of this. So it will be like this, and it will go to the 23. So it will go to the 23. See, this part is, this gap should be 2, है ना? So this will be like this. Okay, so this will be 0. You can see that this point it has 0, this point at 0, now this point at 2, so this point will be at 2, this point will be at 3, this point has been reached to 23, and this point has been reached to 24, and this point at 26. So this is f kilohertz, and the whatever we get in the positive side, we get the mirror image of it. So we get the mirror image, and this is minus 2, this is minus 3, this is minus 23, this is minus 24, and we get minus 26. This is the spectrum of YT. This YT is having the spectrum Y of f. This is the result. So tell me whether it is clear to you or not. Anyone who is having doubt? Anyone who is facing doubt in it? Mirror part of the frequency, yes, I have drawn everything. In this question it is not required, because in this question it has been asked only the positive frequency, but I have drawn the mirror part also, just to clear that whatever we draw in the positive side we get in the negative side as well. Yes, Rohan, I will cover the complete syllabus of communication, but only important topic. There will be some topic that I will not discuss. Thank you, Anurup. So after all this modulation, the 2 times we have done the modulation, one with the frequency 10, another with the frequency 13, and after getting the spectrum of YT, what we observe is we are having the 2 peak values. So we are having these 2 peak values, and these 2 peak values are at frequency 2 kilohertz and 24 kilohertz. So the answer of this question is 2 kilohertz and 24 kilohertz. So the frequency component, the positive frequency at which we get the spectral peak are 2 kilohertz and 24 kilohertz. Okay, so in this question, the question was the positive frequency where Y of f has the spectral peaks. So this is the question from GATE. This is the question from GATE 2004, and now you can see that what is the correct answer. So the correct answer is 2 and 24. So the answer will be option B, 2 and 24. So how many of you have got this answer, and how many of you have understood this particularly first time? How many of you understood this particular concept for the first time and able to understand this modulation? How many of you are able to understand the modulation for the first time? Thank you, Srinivasu. Thank you. So please tell me whether everything is clear to you. So we should go with this pace. Should we go with this pace, or we have to increase the speed? Yes, Shrestha, first time, unique boy. So you have got the everything clear? Yes, Sheikh. Yes, thank you. Please let me know because this is the first class. So we have to be tuned with each other. What you are understanding, what I am saying, everything should be tuned with between us. Then only I can deliver the lecture to you properly. So that is why I am asking that if you are attending this topic for the first time, and okay, Manisha is saying a bit slow, and somebody is saying this increase the speed. Okay, for the first time, see, because of this is the crash course, we will go bit faster in the later of this course, because as I told you that this was the first class, so I was taking bit time, and but in the next class and after that I may increase the speed also. But the important thing is no modification is required. Okay, no modification required. Okay, in the speed. Okay, yeah, I'll take care of that everybody should understand. Okay, so my purpose is to everybody should understand whatever I am going to deliver should be understandable, and it should be grasped by you. So according to that only I will cover that particular course. Okay, so let's finish up this session, and we will be solving a few questions in the next session, and I will be discussing the need of modulation in the next class. Okay. Timing will be same, it will be daily at 6 p.m. at least in the next 4 to 5 classes. If it requires, we will change the time, but according to my schedule it is 6 p.m. is perfect, because I have classes in the morning session and also having one session at 4 p.m. So according to that the time will remain same. If there is any change in my schedule, then only the time will change, and that will be that will be informed by to you by the telegram. So the students, please note this number. Okay, so who are not able to join me on telegram right now with the link provided to you, please note this number and WhatsApp me. So I will give you the link by which you will be easily able to join. Okay. Yes, I will be giving you the PDF of the today's lecture, and that will be with you. Okay, I will give you that PDF also in the telegram only. Coaching is not closed. We are having the live app class. Manisha, you should know GATE Academy has the live app class. So in that we take the classes in the morning session. So the offline campus coaching is not there, but there is a online classes going on. Okay. Okay, so let's finish today's session, and I hope you enjoyed the session, and I will cover the communication system completely in the GATE Academy Global channel with you, and every video will remain same. No video will be privatized, and it will be free of cost for all of you. Okay, those who want to learn, just we want to deliver our content to all the students who want to learn. So there is nothing like partiality, but yes, there will be some other more number of questions will be solved with the paid course, and the more discussion may happen with the paid course students, but in the YouTube we can discuss in this detail. Okay, yes. Okay, Pranjal, you are here also. Thank you. Yes, so everybody should present tomorrow also. The strength should be 100 plus, then only we can have the good session. Okay, so I will request you all to be regular in the class and make the session successful. Okay, and the number of students in every class should be more than 100. Okay, so please share with the students, share with your friends, those who are studying somewhere else. You can tell them also to join here because it is free of cost, so they can also join, and we can make this crash course successful, a grand successful, so that we can have more sessions like that only, like this. Okay, yes, 6 p.m. tomorrow, 6 p.m. okay. So we'll meet you tomorrow in the evening, 6 p.m. okay. Thank you, love you all, good night.